Okay, so we're doing curve sketching here. That's our ultimate goal, is to draw a nice, pretty detailed graph of this function. So first we're going to find our domain. Domain is always an interval notation, and our x and y intercepts. Intercepts are points, not numbers. I see a lot of mistakes here. How do you always find an x-intercept? By setting y equal to 0 and solving for x. How do you always find a y-intercept? By setting x equal to 0. To find either intercept, you set the other guy equal to 0 and solve. And then write those as points. Should know how to find horizontal and vertical asymptotes. Vertical asymptotes happen at places where the function's not defined. Horizontal asymptotes happen when we take the limit as x goes to infinity and negative infinity. I've already done the derivative for you because if you you got to use quotient rule here to take the derivative. And then you got to do a bunch of simplification. And if mistakes happen in the simplification, then everything after here is just wrong. So I've taken the derivative. You could check if you want, make sure I've done it right and simplified correctly. I have. So here's our derivative in simplified form. Now we're going to find our critical values. Critical values happen when the derivative equals 0 or is undefined. So any place that wasn't in the domain is going to go in my sign chart. It probably, places that are not in the domain, vertical asymptotes don't turn out to be critical values because there's no value of the function there. They're not critical points, I should say. They're still values that go in our sign chart. So places here that we said were not in the domain, they're going to go in our sign chart, but they're not critical points because they're not points on the graph. They're vertical asymptotes. Don't forget about putting the bad guy in your sign chart. And then figure out where your function's increasing, decreasing. It's never a constant. Any place where you change from increasing and decreasing and where the function is defined, you're going to have a critical point. Critical points are points, not numbers. You got to find both the x and the y value. And a lot of mistakes happen here. When you go to find the y value, don't use the derivative. You already know what you get here. If you plug a critical value into the derivative, you know you're going to get 0. That's what made it a critical value. To find the y value of your critical point, plug that x value into the original. Similarly down here when you're finding points of inflection. Any place the second derivative equals 0 could be a possible point of inflection. So you're going to do a sign chart. You're going to find where you're concave up, concave down. You're going to put all that information on the graph, all of it, your x and y intercepts, your critical point, label the point, both the x and y values, your point of intersection, if you have one. Okay, that's a good place to stop.